Everybody's here. Good, I got a whole house. All right. So I just want to make a list of the physics we know. Maybe you want to put this in your notes somewhere, maybe you don't. Totally okay with me, as long as you know these things. Okay. Things that you need to know. When I say a particle is at rest, that means velocity is equal to 0. Right? Just, you're at rest, you're not moving. If v of t is the velocity, the derivative of velocity, everybody knows, is acceleration. Acceleration. Okay? If I want you to find speed, how do we find speed? How do we find speed?
Absolute value.
Absolute value of the velocity. This is some of the physics that we need to know. This is some of it. Okay, I might tell you that the velocity is increasing. What does that tell you? If velocity is increasing, there's something else that you know, because you know that the derivative of velocity is acceleration. Velocity is increasing. I see Henry, I see Paul, I see Marilyn, I see Sylvia, I see Garrison. Sylvia, what do you know?
The v prime of t is going to be above the x-axis.
V prime of t is going to be positive. We're going to be above the x-axis, but a better way to say v prime of t is acceleration. So this is the same thing as saying acceleration is positive. Okay? All right, now somebody the other day, and I think this happened just in passing on Friday, they said, wait a second. If I start with velocity and I take the derivative, what do we get again?
The acceleration.
You get acceleration. But what if I took the antiderivative? What would you take the derivative of to get velocity?
The position.
It's position. So there's this chain. If you start with position and you take the derivative, you're going to get to velocity. If you start with velocity and you take a derivative, you're going to get to acceleration. There's that derivative link, that chain that we keep talking about, the f prime, f double prime. So let's come back to this idea that velocity is increasing. Velocity is increasing, that means acceleration is positive. But it also tells you something about position. Velocity is increasing. What's the other thing that you now know? Velocity is increasing, but position is the antiderivative. Paul, what do you know? What's concave up? The position graph is concave up. Okay. These are just some fast facts that I need you to know and be comfortable working with. Here's what we're going to do for the next, we're going to call it 10 minutes. I want you guys working on page 36. I think for the most part, you guys are going to be fine working in your groups. I'm just going to float around, offer advice and support, get people to stop crying as necessary. We'll look at the answers in about 10 minutes, but I want you to get A, B, C, and D done in the next 10 minutes. This hard stuff is coming. This is not it, Sylvia. The hard stuff is coming. We're talking about this. And there's a cat, yes. It's amazing what happens when you Google cat.
Oh my god, I just realized you were super like that.
I feel like that's something. I know what that
I thought that was a sarcastic laugh.
You're right.
You gotta be optimistic.
Grab on here, going on here. 10 minutes, A, B, C, and D. And Gonzalo, did you put your assignment back on my desk? Take it home to show your mother so I can change.
No.
Yes, I can.
Let's get going.
I gave it to you, like, what? No.
Like,
Oh, next one. Oh, yeah. How are you
Give me a graph. Let's get some good stuff going here. Hey, honey. How we doing? Okay, let's get a graph going. Let's get all the good things happening. Jeanette. Okay. So then, did you find the derivatives using the calculator?
So if I could come in and like do the math.
Of course. Absolutely. Nice.
I just go in and I get out. I know what I want.
Can you just write me a note and get started? I'll leave it on my desk. All right, Paul, we're gonna have a little show and tell for you here.
Are you trying to point
Wow, that's great.
7 minutes. Okay. Hopefully you've got a good looking graph like Paul does. Hi. Top shelf, yes. Increase in the cat's height above the ground. The cat's not getting taller. Okay, that's a good graph. Paul's got a good graph. Make sure you can see the high highs and the low lows. Karina, you doing okay?
Go. We have similar in the same period, right? Yeah, bit period.
Paul, you're definitely generating good values back there. I like it. I like both of them. I like both of them. Yeah.
Yeah. Like a medicine?
Find the acceleration of the cap and the velocity.
Take care.
And the velocity.
One was the early morning.
Okay. So now I need you to find the acceleration there. How do you find the acceleration?
It looks. Oh.
You tell me you for sure, but at the minimum, what's the acceleration? Why?
No, like when it starts, you were already like told your shit, right? And then it goes negative.
What's happening at the minimum?
Looks like an outflow.
Acceleration derivative of the velocity.
Yeah.
How does that help?
For real?
I need you to consider something.
She was really talking. You got drink the wine?
We're drawing a candle line at the minimum.
You get a roof.
The slope is.
It looks so. Zero. Oh,
So the velocity function at its minimum will have an acceleration of 0 because the candle line is working.
Can you tell me what's B of 1.5? What's B of 1.5?
Yeah.
Is that really bad for you?
Velocity is
I think I really think that's bad.
acceleration.
But mine wasn't that bad. Like that was even
No, like they're making like she got better. No me estoy en medicina hoy. Es negative 3.36.
negative.
Minute and a half.
Negative 7.8.
I don't know.
Pierce through it.
Well, there's the load. I could use that. If you need to turn it real quick.
But this one is testing get some here since you're not.
And I'm confused.
Yes, ma'am.
T equals 1.5 seconds of velocity decrease over the rate of 7 meters per second. Oh, so what I don't like here is the velocity and the velocity didn't decrease. Because velocity of 1.5 is negative 3.361. It's not decreasing, it's not increasing, the velocity is that amount. Yep.
I have a suggestion.
Yeah.
When it comes to finding your videos, it's really hard to find, like in a YouTube channel. Is there a way that you
Yeah,
could do
it's that's what's calculus.
I can't find it because like too many users come up.
I'll send it to you. I'll send the link to the channel.
Alrighty, friends, we're gonna go over this real quick, Paul. I'm gonna take that away. Here we go. Oh, here we go. Okay, number one, there's your graph. Nothing too surprising there. Okay, part B, V of 1.5 is negative 3.361 or negative 3.3613. V prime, the derivative, is negative 7.8430. At this point, I would expect every single person in this room can find those numbers and find them easily. Okay, I care greatly about your explanations. For the velocity, at time t equals 1.5 seconds, her velocity is negative 3.3613 meters per second. You could also use your physics knowledge and say the height is decreasing. Not the height of the cat. Don't think about the cat melting. but the cat is like digging into the ground. She's super cat, she can do these things. V prime is at time t equals 1.5 seconds. Her velocity is decreasing at a rate of 7.8430 meters per second squared, meters per second per second. That's fine. For those of you that know that the derivative velocity is acceleration, you could also say at time t equals 1.5 seconds, her acceleration is negative 7.8430 meters per second squared. That's fine. Okay, part C, determine the acceleration of the cat when the velocity is a minimum. Well, if the velocity is a minimum, and this is the conversation Henry and I were having, the minimum's happening right over here. What do we know? What has to be true about the acceleration at the minimum? Acceleration is the derivative of velocity. Derivative is telling you slope of the tangent line. If I said, hey, what's the slope of the tangent line at the minimum, what would everybody tell me?
0.
0. So what's the acceleration at the minimum?
0.
Has to be 0. Has to be 0. Now, if what you did with your calculator, I'm curious, did anybody do this like you found the coordinates for the minimum? And then you found the derivative at that point? And you don't get 0, you get like 0.007, you get something close to 0? That's because your calculator is struggling with the accuracy. This could also just be a conceptual question, Diego, where I'd say, hey, here's a velocity graph. What's the acceleration at the minimum? 0. Are we good? All right, let's pick it up from here. I don't know that many people made it to part D, so let's start the conversing here. Part D, on what interval is the cat's height decreasing and acceleration positive? I need height decreasing height decreasing, acceleration positive. And what you have, the only thing you have, is the graph of the velocity. I need for you to connect me back to the graph. Okay, so let's go back to the graph. I want to get some hands on this. What has to be true about the graph? This is great practice for that formative assessment tomorrow. You have velocity. Marilyn, what do you know?
For acceleration to be positive, it must be increasing.
If acceleration is positive, not it, but the velocity is going to be increasing. Great, I can look at my graph. I know where velocity is increasing. But what about height decreasing? How does that connect back to velocity? Jeanette, what do you know?
It has to be below the x-axis.
V of t has to be below the x-axis. V of t has to be negative. So the answer to the question is, where is height decreasing and acceleration positive, is really the answer to the question, where is velocity negative, oh, and at the same time, increasing. So that should be from this minimum, which Paul has as 2.41, 2.414. And where do we stop being negative and increasing at the same time? And this should happen at 3. Paul, what's up? You're good? Friends back here, we're okay? You know.
What if I estimated 1.5 from the graph?
Okay, gosh, thank you for the question. Please don't ever do that. You have your access to your calculator. Your answers have to be accurate to 3 decimal places. Don't eyeball it. Don't eyeball it. Are all the friends okay?
Mm-hmm.
You know who I'm looking at, Andy. Okay. Part E, for right now, we're going to skip. We're going to skip part E. What I am very interested in is what you can do with part F. Using the graph of the velocity, sketch the acceleration function. When you're finished, sketch the acceleration function on your calculator. So first by hand, have those conversations going. Second on the graphing calculator, I want to make sure you get the skills.
Would the zeros here be the horizontal axis? Or
Well, I think it's like this. After 1, 0, 0 goes from negative to positive, so the minimum.
I just know know this goes like this. This is that's like
Yeah, that's right. This one, when it goes like that, it gives it to minimum solution. I'm trying to think of
I'm guessing it's
Paul, if you don't mind, can you, yeah, let's get rid of F2 for a little bit.
if it's increasing, it's constant. This is E.
All right, things that I'm hoping are happening here. You know you've got a horizontal tangent line here. You got a minimum. So the acceleration graph has to have a root.
I can't look.
Other things I'm looking for, I can see velocity graph is decreasing. So the acceleration graph
Should be below 0.
has to be below, and I'm not looking for it to be like perfect, but I want to make sure, Diego, that if you tell me velocity is decreasing, acceleration is going to have to be negative. This is what I care about. Okay, and then I know after this minimum, acceleration is, I'm sorry, velocity is increasing, so acceleration has to be,
Above.
it's going to have to be positive, it's going to have to look something like that. Henry?
But I thought at the very beginning of the problem it said that it had a point of inflection.
Oh, we know about a point of inflection.
Yeah.
Where?
1.26262.
Oh, okay, so I just told you something about a point of inflection at t equals 1.262. Thank you for making me a better math teacher. Okay, so I want to fix that. So there's two things on this interval that are true about velocity. Two things that are true about velocity. One we've already talked about, we said decreasing. The second one has to do with the concavity, the way the graph is bending. What kind of concavity?
Concave down.
Concave down. Right, on this interval until I hit point of inflection, decreasing and concave down. So if we're decreasing and concave down, what's true about acceleration? Acceleration has to be negative, and acceleration has to be decreasing, not concave up. If the velocity is concave down, then acceleration, the derivative, is decreasing. If you're not sure, think about it. You got position, velocity, acceleration. Velocity concave down means that its derivative is decreasing. It's that f prime, f double prime. So I need to draw a graph that is negative and decreasing, so I could do like maybe that. Once I hit the point of inflection, my graph is now, what is that, decreasing still, but concave up. So my graph has to remain negative, but now increasing to get to that root. Roughly, that's what I'm looking for. And if you double check it on your calculator, you're going to see exactly that graph or near enough to that graph. We're negative, we hit the relative min, we start to increase, and we go positive. All right.
I don't understand the decreasing part. Like, when it comes, if it's concave down, would it increase first and then decrease?
Well, first of all, you keep using the word it, so I don't really know what we're talking about anymore.
If Roberto would stop speaking out loud, and then if V is concave down,
V is concave down.
right, and then we look at the acceleration.
We look at the derivative, which is acceleration.
So wouldn't it increase first and then decrease?
No, concave down means that your derivative is decreasing. I think what's happening, Eval, you're thinking concave down looks like that, which is true. And you're saying that the velocity increases and decreases. That's true. But the acceleration, you're talking about the slopes of the tangent lines. The slopes are positive, less positive, 0, negative, more negative, more negative. What's happening with those slopes? Those slopes are decreasing. Okay, moving on. Let's keep going. All right, from the velocity graph, let's move on to the next one. I need you to sketch the speed function. Sketch the speed function, then graph the speed function by hand.
Just the absolute value.
Basically everything possible.
He said that whenever the size are different, it's decreasing, right?
We know that the speed is the absolute value of the velocity.
So velocity like is positive, negative. Like that brief moment, and then that's increase again.
But we just know the absolute value, just take the absolute value of
The absolute
velocity.
value of velocity. So when you
That's
take the
something
absolute
else.
value,
There's something else.
you take the absolute value of a positive number,
If
what
it's
happens?
speeding up or speeding down.
Nothing happens, right? What if you take the absolute value of negative? The absolute value of -6 is +6, right? The sign changes, but the number doesn't, right? It goes from -6 to +6. On your graph, what's going to happen? Any part where the graph was above the x-axis, you're going to stay above the x-axis. But any part where you were below the x-axis, gets reflected. Okay. All right, Paul, can you show us what the speed graph looks like? Everybody good with the speed graph? Mm-hmm. Like, we've all got this under control? By hand and on the calculator. Calculator ought to be easy, but the speed function, I need you to be able to like graph it by knowing about reflections and knowing about the absolute value. Okay, good. The next question is, based on your speed graph, based on the speed graph, determine where the speed of the cat is increasing. I'm looking for intervals now. When is the cat's speed increasing? There's like one or two questions for all the more missed. So there's something important. So one thing I recommend, make this your log, polish your domain so that you have 0.5. All right, Paul, we've got a whole bunch of stuff happening on the screen. Can you maybe delete the stuff that we don't need? But if you hit delete all, I think you're going to get rid of the function as well. Oh, I don't want you to do that. Okay, never mind. Escape. All right, Jeanette, how are we doing with where the speed is increasing? Is this H?
Yes.
Okay, speed increasing. Okay, Jeanette, what intervals is speed increasing?
From 0 to 1.
From 0, Jeanette says that the speed function is going to be increasing from 0 to 1. I don't agree. And looking at some of the faces in the room, I don't think you guys agree either. The speed function. The speed function is this guy here. Boom, 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 boom. I just need to know where speed is increasing. Karina, where's that going to happen?
From 1 to the 2.4142.
From 1 to 2.414. That's going to be this interval over here. From that first root up until I hit what is now my maximum. And Sylvia, where else? 3
to 4.
Oh, be careful. From 3 to 3.5. You don't want to talk about anything outside of this interval. From the speed graph, is everybody okay with speed increasing? For sure? Okay, so now I want to push your thinking a little bit more. All right, get rid of that speed graph, please. Get rid of the speed function. You can do this a couple of different ways. So Paul's showing off all his skills today. If you typed in F3 or F2 as absolute value of F1, click in front of the F3 and it'll just go away. It'll just go away. It's not going to delete the function, it'll stop graphing the function for you. All right, so now we're back to velocity function. And here's what I want to pay attention to. we already know if the speed function was in front of you where the speed is increasing. We know it's increasing from 1 to 2.414 and from 3 to 3.5. Everybody okay with that? I don't have the speed function in front of me, but I want to partition this up. I want to chop this up so that we can look at the graph maybe a little bit differently. What's the speed function doing in this first interval?
Decreasing.
Speed is decreasing. Okay, over in this next interval, speed is increasing. Now, I want to be careful, because some of you might be like, but wait a second, this function is decreasing. This isn't speed, this is velocity. There, I'm going to put you in situations where you won't have the speed graph in front of you. You'll have the velocity graph in front of you instead. Rebecca, are you okay? Okay, speed is decreasing here, speed is increasing here. This next interval, what's the speed doing?
Decreasing.
Speed is, wait, increasing or decreasing?
Decreasing.
Decreasing, speed decreasing. This last interval?
Increasing.
Speed increasing. Okay, I want to come back around. Let's look at velocity. Tell me about velocity. Velocity on this first interval. Decreasing. V of t decreasing. On this next interval, what's velocity doing? Velocity is decreasing. This next interval? Velocity increasing. This interval? Velocity increasing. Now let's look at the sign of the velocity. The sign of the velocity in this first interval? Positive. Sign over here. Negative. Sign over here. Negative. Sign over here. Sign over here is positive. Okay. So picture, if you can, don't look at that graph, a velocity curve. The velocity is positive and increasing. Velocity is positive and increasing. What's the speed doing?
Increasing.
Velocity is positive and increasing. So you're already, you're imagining like this guy here. You're above the x-axis and that velocity is increasing. What happens when you take the absolute value? Speed's still increasing because the velocity was positive to begin with. The absolute value does nothing. Okay, let's try another one. Velocity is negative and increasing. Velocity is negative and increasing. What's speed doing?
Decreasing.
Velocity is negative. You're below the x-axis. And then I said what? Increasing?
Yes, sir.
Imagine increasing. Velocity negative and increasing. Take the absolute value. What happens? Negative and increasing. Take the absolute value. What happens? You're now positive, but you're decreasing. Okay, velocity is positive and decreasing. What's the speed doing? Velocity is positive and decreasing. Speed is decreasing. Velocity is negative and decreasing. Speed is increasing. Okay, let's make it even a little bit nicer because I really care about you guys. Let's go back through these intervals. If the velocity is decreasing, what do we know about acceleration?
It's up below the x.
Negative, right? Velocity decreasing over here, acceleration? Negative. Velocity increasing over here, acceleration?
Positive.
Positive. Velocity increasing over here, acceleration? Positive. Make a connection between velocity, acceleration, and speed. I see Paul. I see Karina. Connection between velocity, acceleration, and speed. I see Marilyn. Velocity positive, acceleration negative. What's speed doing? Velocity positive, acceleration negative. What's happening? Speed is decreasing. You're seeing something?
Yeah.
What are you saying?
That whenever like speed and velocity are going like the same way, acceleration is
I'm looking for a connection here at the velocity acceleration level and how it automatically tells you speed. Daisy, what do you see?
and velocity and acceleration have the same sign.
Velocity and acceleration have the same sign.
Then speed is increasing.
Speed is increasing. Velocity negative, acceleration negative, speed increases. Velocity positive, acceleration positive, speed increases. What about when they have different signs? Velocity positive, acceleration negative, speed is decreasing. Velocity negative, acceleration positive, speed decreasing. I would get that in your notes. Karina.
So if they have both of them are negative, then it'll be increasing.
If both of them are negative, the both being velocity and acceleration, if velocity and acceleration are both negative, speed is increasing. When the signs are the same, speed increases. When the signs are different, speed decreases. Everybody mostly okay? Henry?
So
Yep.
So you teach it as is, you're gonna make this number like this, and then.
Oh gosh, I'm going to make you do all sorts of things. But a thing that is going to be true all the time, and Andy, this is what you asked me to repeat. If velocity and acceleration have the same sign, speed increases. If velocity and acceleration have different signs, speed decreases. All the time. All the time, all the time, all the time. Pretty good? All right, I want to push just a little bit more. You know me, I'm a pusher. I want to see what we can do in part, I think it's part J. I want to sketch the graph of the cat's height above the ground. I'm going to blow your minds at least a little bit here. And this is getting us to the antiderivative, Jalissa, so I'm so glad you're here.
Just position.
I want position, I want height above the ground. What we're told in the beginning is that the cat's height at the very beginning is 0, it's on the ground. I'm looking for stuff that is true about velocity and what that means about height. For example, the velocity is, what is it? It's decreasing and positive. What's true about height? Height is the antiderivative. Henry, what's true?
That means that height is, it's below the x-axis. No.
Not below the x-axis. It's the antiderivative. Velocity is decreasing. Height has to be concave down. And velocity was positive. That means height is increasing. So what I would sketch is concave down increasing on that little interval. We're going to talk more about this tomorrow and Wednesday. Don't freak out about this. The homework tonight that is absolutely getting picked up tomorrow, I don't care how much you guys whine or cry at me when you come in, are those multiple choice questions. We're going to have a short 15-minute quiz on f, f prime, f double prime, all free response tomorrow.